Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. In this video, we will be taking up the concepts of concentration terms which are a part of our module solutions. Okay. So before starting, let us have a brief idea from where this concentration terms comes from. First of all, we all are aware with the word mixture. Mixture, right? Mixture means it is a combination of two or more compounds in any proportion, right? So if I'm saying sugar solution, salt solution, it's a mixture of sugar and salt, or sugar and water, salt and water. It's basically a mixture, right? So mixture is a combination of two compounds in any definite proportion. Now mixtures are further classified as homogeneous mixture and heterogeneous mixture. Now, what do you mean by homogeneous mixture? Homo means same, right? So, if throughout the bulk of the mixture I am getting equal proportion of the solute and solvent, it is called as a homogeneous mixture. Okay. If I am saying sugar solution, for example, here I am mixing to this, I am mixing some sugar, I am dissolving it to make a sugar solution. So, if I take a spoon of that solution from the surface, that will taste sweet. If I take that from the bulk of the liquid, that will also taste equally sweet, right? So, basically here sugar has spread out in the entire surface of the or the entire volume of the liquid in uniform proportions. But in case of heterogeneous, what happens? Non-uniform distribution happens. For example, if I am saying to water, I am adding a scoop of sand. Then what happens? If I leave it alone, like as to remain it stand over for some time, I will see the sand particles getting deposited at the surface because they are heavier, right? So if I take a spoon from the surface, that will have different amount of sand, and from the bulk that will have a different amount of sand. So that's how I classify mixture as a homogeneous one and a heterogeneous one. Then I come to solution. What do you mean by solution? Solutions are basically combinations of solute and solvent. Okay, solutions consist of solutions. They consist of solute and solvent. If whatever the compound is, if it is present in greater amount, then that will be the solvent, and the one that is present in lesser amount will be the solute. So if I say sugar solution, that means to sugar, to the like water I am adding sugar. So water is here as it is present in bulk. So water is the solvent and sugar is the solute. Okay. So now from solutions I derive or I come down to a term called concentration. Now what do you mean by concentration? If I am saying sugar solution, then I can add little bit of sugar in one solution, and I'll take another beaker to which I'll add a lump, like bunch of sugar in it. Okay. So what happens? The one which has lesser amount of sugar will be a dilute solution, and the one which has more amount of sugar will be a concentrated solution. So concentrated solution, concentration means basically the amount of solute that is present in a definite amount of solvent, right? So to define to define the amount of solute which is present, I define or I make use of some concentration terms which we will deal in this chapter. So in solutions, a solution is a homogeneous mixture of two or more pure substances whose composition may be altered within certain limits. Though the solution is homogeneous, yet it retains the property of its constituents. Generally, solution is composed of two compounds, one is solute and another one is solvent. Such type of solution is called as a binary solution, means it has two components. Okay, one is the solute component, one other one is the solvent component. Solvent is that component in solution whose physical state is the same as that of the solution, which while the other component is called, if physical state of both the component is same, then the component in excess is known as the solvent, and the other one is called as the solute. Each component in a binary solution can be in any physical state such as solid, liquid or gas. Okay, here are some examples of solution. If I am saying a gaseous solution, then the solute or the solvent has to be a gas, and it can be a gas solution, liquid gas solution and solid gas solution. If it is a liquid, then the solvent has to be a liquid, and it can be a gas liquid, liquid and solid liquid. Similarly for solids also, gas, solid and liquid. Okay. Next I'll come to the concentration terms. So the concentration of a solution is the amount of solute dissolved in a known amount of solvent or solution. Solution can be described as dilute or concentrated as per their concentration. A dilute solution has a very small amount of solute, while the concentrated solution has a large amount of solute in solution. Okay, so various concentration terms are, the first one is mass percentage. Mass percentage means the amount of, it can be said as mass by mass percentage. That means it is defined as number of parts of mass of solute per 100 parts of by mass of solution. Basically it means weight of the solute divided by weight of the solution into 100. Okay, weight of the solute divided by weight of the solution in into 100. So if I am saying a 10% sugar solution, that means I am adding 10 grams of sugar in 100 grams of solution. That is 10 percentage of, that means a 10% sugar solution. Next is mass by volume. It may be defined as mass of solute present in 100 centimeter cube of solution. If 100 centimeter cube of solution contains 5 gram of sodium hydroxide, then mass by volume percentage is 5%. Okay, it's basically weight of the solute by volume of the solution in into 100. Next is volume percentage. That means volume of the solute divided by volume of the solution into 100%. Okay. So it can be represented as percentage V by V and is used to prepare such solution in which both components are in the liquid state. Volume by volume. Okay, it is the number of parts by volume of solute per 100 parts by volume of solution. Got it? Now mole percentage, that means moles of the solute divided by total number of moles. So mole percentage can also be said as mole fraction, which is moles of the solute by total moles of the solution into 100. Again, mole fraction, what does that mean? If it has more number of components, right? For example, mole fraction can be defined as the ratio of number of moles of one component to the total number of moles of all the components. Let's say I'm adding salt, sugar, both into water. So the mole fraction of salt will be number of moles of salt by total moles of salt plus sugar plus water. Okay, that's how mole fraction is calculated, which is moles of solute by total number of moles. Okay, here it is not percentage, it's simply total number of moles of solute by total number of moles. Mole fraction does not depend upon temperature and can be extended to solutions having more than 2 components, as I said. Okay. Next is the important one, which is molarity. Now molarity is the common unit of concentration. It is mostly used. It is defined as number of moles of solute per 1 liter or 1 dm cube of the solution. Okay, molarity means number of moles of solute divided by volume of the solution in liters. Now if I see molality, it is the number of moles of solute by mass of the solvent in kgs. Okay, the number of gram mole of solute present in 1000 gram of the solvent is known as molality of the solution. Now unit of molality is mole per kg and it is not affected by temperature. Okay, molality is the only concentration term which is not affected by temperature, because both the terms are mass, okay, related to mass, and masses are not affected by temperature. But if I see molarity, then volume is definitely a component dependent upon temperature. So with the alterations of temperature, the molarity changes. Now this is parts per million. It is very low concentration. If the concentration of solute in the solvent is very low, then we use parts per million. It can be represented as ppm. Okay, parts per million. It is the number of parts by mass of solute per million parts by mass of the solution. So we have to multiply a million component, that is 10 to the power 6. Okay, so it is mass of the solute by mass of the solvent into 10 to the power 6. Okay. Now, here are some certain questions before you which we will deal in order to get the concepts more clearly. Okay. First is, calculate the mole fraction of components of the solution composed by 92 gram of glycerol and 90 gram of water. Okay. So here molar mass of water is given as 18 and molar mass of glycerol is given as 92. So from here you can calculate the number of moles of glycerol as given mass by molar mass. So if I am saying 92 gram is given, then given mass by molar mass, here it comes out to be 1 number of moles of glycerol. Number of moles of water is, again, given mass is 90 and molar mass is 18. So number of moles, like moles of water comes out to be 5 moles. Okay. So total we have 1 mole and 5 mole. Mole fraction of glycerol will be 1 by 1 plus 5, that is 1 by 6, and that of water will be 1 by 1, sorry, 5 by 1 plus 5, that is 5 by 6. Okay. Now, what will be the molarity of solution when water is added to 10 gram of calcium carbonate to make 100 ml of solution? So what I have said is molarity means number of moles by volume of solution. So here it is given 10 gram of calcium carbonate is taken. So you have to find the number of moles of calcium carbonate, that is given mass by molar mass, and the molar mass of calcium carbonate is mass of calcium is 40, carbon is 612, and oxygen is 16. 16 3 is okay, 16 into 3, which is 48. So 88 and 12, it is 100. Okay. So molar mass of calcium carbonate turns out to be 100. So number of moles will be 10 by 100, which is 0.1. Now we have to find molarity, which is number of moles by volume in liters. So it is 0.1 and volume is given to us in ml. So we have to multiply 1000 to make it into liters. So it gets cancelled out and I get 1 molar. Okay. Next is calculate the molality of the solution containing 20 gram of sodium hydroxide in 250 grams of water. Again, number of moles of sodium hydroxide you have to find out, which is 0.5 moles, and 250 gram of water, that turns out to be 0.25 kgs of water. Hence molarity is number of moles divided by mass of the solvent, which is 0.5 divided by 0.25, and it comes out to be 2 molar. Okay. Now calculate the grams of copper sulfate needed to prepare 250 ml of 1 molar solution. Okay, it's basically the interconversion thing. So what happened? Number of moles of CuSO4 is equal to mass by volume, because, sorry, molarity by volume, because we know molarity equals to number of moles by volume. So number of moles equals to molarity into volume. So molarity into volume, molarity is given as 1, right? And volume is given as 250 ml, and we have to convert it into liters. So 250 by 1000. Therefore, the mass of carbon dioxide, sorry, the mass of copper sulfate comes out to be 159.6, and the mass of copper sulfate is number of moles into molar mass. Okay, this is the molar mass of copper sulfate, and moles were found out to be, we have to calculate this, 0 gets cancelled out, 1 by 4. Okay, so basically here we have to see 159.16 into 1 by 4, which is 39.9 grams of copper sulfate. Okay. Next is how many grams of H2SO4 are present in 500 ml of 0.2 moles H2SO4 solution. Same again, here you have given the volume of H2SO4 and molarity is given as, molarity is 0.2 molar and volume is given as 500 ml, which is 0.5 liters. Okay. Now if I calculate the number of moles, then number of moles equals to molarity into volume, which is 0.5 into 0.2, it comes out to be 1. Okay, number of molarity or number of moles comes out to be 1. Here what you have to find out, how many grams of H2SO4. Okay, so now what we know is number of moles equals to given mass by molar mass. So mass is 1 into molar mass, and the molar mass of H2SO4, if you find, is 2 plus 32 plus 64, which is 4, 5, 6, 7, 8, 98. Okay. So 1 into 98, that is 98 grams. Got it? So I hope you understood how to calculate the concentration terms. These were all about the concentration terms. In the later videos, we will be taking up further the colligative properties of solutions. Till then, thank you so much for watching.